So in this lesson, we're going to look at how we can use properties of graphs to keep track of how graphs behave. So some of the properties we're going to look at are domain and range, and how we can use domain and range to determine how a graph's going to look or behave. And also we're going to look at transformations and how we can use transformations to see how a graph is going to look or behave. So let's look at the domain and range idea first. So when I take a look at the square root function, the domain of this square root function, okay, is, well, if I square root, if I put 0 in here, I'm going to square root -2. I can't square root 0. So the domain is restricted here. And the smallest number I can put in for x is going to be x equals 2. Okay, so my domain is going to start at 2. Change colors here. So my domain is going to start at 2, but it's got to be bigger than that. So it's got to be bigger than or equal to 2. Okay, and I'm just going to put in here, this has got to be real numbers because it's a continuous variable. So my domain is going to look like this, and I'm not going to do it the fancy way with the curly brackets and everything. This is good enough. So my domain is going to be x is bigger than 2 because there seems to be a restriction based on I can't square root certain numbers here. So domain is really important. The range is kind of secondary, so if we can figure out the range, that's great. If we can't, sometimes it's just too complicated to figure out range, so sometimes we're just going to avoid dealing with range. But the range of this function is pretty straightforward. We know that we can start at 0. When we square root 0, we're going to get 0, and we're going to get all numbers above 0. So my range is going to be y is greater than or equal to 0. Okay, and the y is a real number because it's a continuous variable. And when we graph this, we're going to have our graph look like this. Basically, it is a square root function with a vertex at 2, 0. Okay, so that's pretty straightforward. But what is the property that determines how this thing behaves? So why does it start at 2? Okay, well, the property of the domain, and again, it says domain range, but really we're most interested in the domain. What's the property of the function that makes this domain possible, or makes it have the domain that it does? And it's this issue that the square root, we cannot square root negative. Okay, so we cannot square root negative. So that's a property of this function that's causing the domain to look like this. So we cannot square root negative. Okay, so anything inside that's negative, we cannot square root, so we end up all the x values from here, that way, no go. Okay, we can't have any of those. Now the domain boundary is going to be at 2. Okay, and it's because what is the smallest number that we can square root? Okay, so the domain boundary happens at x equals 2 because the square root is equal to 0. The inside the square root is equal to 0. Is equal to 0. Okay, so we get 0 inside there. And so that's our boundary. 0 is our boundary for square roots. Okay, and that's important. We want to make sure we establish that and we kind of recognize that and use that when we start seeing these square root properties. So that's a big property of square root, is that we cannot square root negatives. And so we want to be able to kind of think of domain and range in terms of how these can be restricted, how the function restricts itself. We could also think of domain and range from a different perspective. So there's two things we're going to look at. So domain and range. The other is transformation. Okay, we can think of a translation of this function. So basically we have our original function. Its domain starts at 0, 0, and it goes to the right and it goes up. Okay, and we know that this graph has been, the transformation was we go x goes to the right. So we go plus 2 to the right, okay, or right 2. So we know that if we transform this to plus 2, our original starting point just shifts 2 over, okay, and then we get a new domain from this point. And so we can think of these as two different strategies. One is to think of the domain restriction based on the actual function restriction. The other way is we can think of it in terms of a transformation. We're just starting with, we have a starting point, we know the transformation, we know the ending point, we know how the graph behaves. So we know that our domain is going to start at 2. Now, these are complementary ways of thinking. We don't need to use one exclusively over the other. Sometimes it's easier to think one way, sometimes it's easier to think the other. Sometimes it's easier to think, oh, what's happening to this graph because of the restrictions on the domain, on the function. Okay, I can't square root negative. Sometimes it's easier to think of this, well, I know my domains change because of a transformation. Okay, so these are complementary ways that we can start thinking of how functions behave. And the specifics of this are not as important as just understanding the general idea that we want to start looking at properties of graphs to understand how they behave.